Good morning, everyone. Thank you for joining us on today's webinar, which is brought to you by Paratus through the Disaster Risk Stakeholder Hub. My name is Ben Hall. I'm from the Resilience Advisors Network, and I am one of the facilitators of CMINE, the Crisis Management Innovation Network Europe, which is the platform that you hopefully signed up through for today's webinar. I'm joined from members from the Paratus and the Safe Place projects, who I will introduce to you shortly. Thank you for joining us today. From speaking to many of you in the build up to this, you're all sitting in dark, wet countries. So hopefully this will bring a little bit of sunshine to the day ahead. So I'm going to give you a real quick introduction to the Disaster Risk Stakeholder Hub, what it does, what it's growing and what it's trying to be. And then I will hand over to Sonia for the main part of today's webinar. So as you can see there, you've got a link to the DRS Hub website. You can also access it through the CMINE platform. And it is an entry-level reference point for anyone who's involved in disaster risk management. So what I mean by that is it's meant for citizens, local organisations, responders, regional authorities, local authorities, researchers, policymakers, anybody at all who's got a bit of an interest in disaster risk management. It's originally stemmed from the Paratus project, who began the building of it, and it's engaged stakeholders from across case studies in regions like the Caribbean, Istanbul, Bucharest, and the Brenner Corridor. And it really recognises the need for a universal platform. Its scope, fortunately, has since expanded. So some of the features you can find on the hub at the moment are baseline knowledge and tools. So it's got terminology, disaster databases, impact chains, hazard data. It's got a simulation engine. So it features interactive tools such as impact chains, generators, hazard assessment tools, risk assessment tools, things like that. It's got an area for community engagement, which hopefully is where you found today's webinar. It's got a members forum, an area for events hosted by either projects, local governments, again, anything related to disaster risk management. It's got an intelligent search engine, so an AI search function. So you could just type in something like flood and it will throw up everything within that disaster database to do with flood. And that may be useful for you if you're a responder, policymaker. There's a wide variety of stuff there. And it also has links to complementary tools, so other platforms such as Cordis and the UN's Disaster Risk Gateway. Some of its other benefits is it enables greater project longevity. So what we mean by that is your tools, your platforms, anything that the Horizon projects throw out at the end, there is an area to host them so that they can be found by future projects or the stakeholders that would like to have access to them. It really supports that sustainability cycle. It's a central access point, so all the stakeholders know this is where they can go, this is where they can get this information. And it's an opportunity for projects to store resources, share findings, and enhance engagement. And the DRS Hub webinar series that's brought to you by Paratus is a collaborative thinking, bringing together between 15 and 20 projects to share findings, share results, and really engage with the community on a cluster level rather than an individual project level. And with that, I'm going to hand straight over to Sonia. Thanks, Sonia.
Thank you, Ben. Good morning, everyone, and welcome to this webinar of the Disaster Risk Stakeholder Hub series. This is the fifth webinar we do, and we hope you followed us since the beginning, or if you are first to the series, hopefully the introduction by Ben helped you to understand why do we do this type of activity. So today I will moderate the webinar From Space to Action, leveraging space data and interactive scenarios in disaster risk management. We would like to have this as an informal space, so feel free to leave your camera on and pop your questions and comments in the chat. We will have a dedicated time at the end for sharing questions, but you can also anticipate them in the chat and we will collect them throughout the presentation. So if we go to the next slide, you can see the agenda for today. So after this welcoming introduction, we will see and get to know two projects. the Paratus and the Space, the Safe Place project. And then there will be a short panel discussion where we will explore the sustainability of the project outcomes. And at the end, as already mentioned, we will have time for jointly discussing what has been presented and also share suggestions or ideas for further collaboration. So we strongly encourage you to actively participate in the webinar and use this space to work together and jointly think about these important topics for disaster risk management. So, without any further ado, I would leave the floor to our first speaker, Bastian from the Paratus project. Bastian, the floor is yours.
So, hello, good morning, good afternoon, everyone. Am I audible? Can you all hear me well?
Yes.
Wonderful. Um, yeah, so happy to be here. My name is Sebastian van den Bout. I'm involved also with the Paratus project. I work at Twente University part-time and part-time at a spin-off that me and then some others founded called Fast Hazard. We'll get to that in a little bit. Next slide, please. And next slide after that. Yeah, I think most of you know this maybe in the audience here, but just to give sort of a general introduction to sort of the overarching project and a little bit the role that I have within that and the activities that I'm involved with mostly. Praatse has been running now for three and a half years. So it's about 19 partners, I want to say 20, spread throughout Europe. Case studies also spread throughout Europe and also heavily in the Caribbean region. St. Lucia, St. Vincent, Dominica, St. Maarten. And one partner, Asian Institute of Technology in Bangkok. It's really focusing on multi-hazard platforms for systemic risk assessment. And yeah, getting sort of also at the core of the topic for today, the project really attempts to co-design these platforms with stakeholders and also place the right side, yeah, sense of ownership and continuation with the stakeholders so that some of the deliverables that come out of the project will actually have a lifetime that exceeds the project itself, hopefully by many decades. Um, Yeah, so there's parts of looking back, looking into history, forensics on historic disasters, particularly with an interest in multi-hazard events, but then also using the knowledge that comes from that to go towards hazard vulnerability and also financial risk, looking ahead into the future. Next slide. Um, Oh, yeah, there we are. I think there might be some lag between the video, the screening compared to the audio. Um, yeah, so like I said, learning from the past, that's the part at the top here. So looking at impact change, change itself, so how different processes that interact as a part of a multi-hazard event, how they come together and cascade into newer processes. And this is also really where there's a really tough challenge at the moment in the science to understand how these cascading change of hazardous processes, how they occur together. And what the probabilities are of this cascade continuing towards other processes. Think of a tropical cyclone impacting. We've had several in the past weeks. Think Cuba or Jamaica, think Sri Lanka or Vietnam, the Philippines. Often you see there it's storm surging, it's flooding, it's landslides, it's debris flows, it's wind damage, and they're all occurring at the same time. And there's all these kinds of interactions that happen between them that make that they have very particularly exaggerated risk in certain for certain sectors or simply for certain populations. So it's really trying to capture that and using some of the tools that we're developing, serious gaming, but also analysis and modeling tools, where I am mostly trying to do a better job of predicting that in a systematic way going into the future. Next slide. There we go. Yeah, Yeah, again, you might notice already a little bit. There's the information service stuff and then the simulation service. I'm heavily on the simulation service side, the fast hazard modeling stuff. That's what I do. And then we're hoping to, in the end, have that linked and combined with risk calculation. So there's sort of tooling that is straightforward to use by decision makers to go from historic data and information towards modeling hazards, looking at decision making, but also risk information and feeding that into the decision making process, right? To make that as easy and accessible as possible in a way that they can actually find it useful. The next slide. Yeah, so yeah, part of that is the serious games and collaborative decision making processes that are done within the project. There's been several games now that have been developed and used with stakeholders to explore hazard scenarios and try to come up with sort of out of the box solutions to reduce disaster risk within that. Next slide. There we go. Yeah. So this is mostly where I am at the moment. The fast hazard models. So basically, around the time when we sort of started this, we stumbled, yeah, partially a bit by accident on a very rapid way to simulate flood hazard. Now, what the yeah, sort of core of that is we skip the traditional requirement to do time step by time step animation of the actual dynamics of the event, but we directly compute the hazard maps, so peak flood depths, peak velocities, etc. So we're looking at sort of information that you would typically also use when you're doing hazard assessments, risk calculations, etc. And that's really something that works near instantly, right? So, sort of as part of that hazard modeling yeah, effort, we've worked on a version for flooding, for landslides, and hoping eventually to get to other hazards as well. Also with the opportunity to simulate interactions with them. I'll show you a little bit how that works and what that does as well. Next slide. Yeah. So for the project itself, Fast Flood and Fast Hazard, we actually are doing most of now the implementation, development, and operation of this as part of this spin-off company, Fast Hazard. So I am there with half of my time, and the other half I'm at the university still doing research on this stuff, and the other half is trying to put commercial tooling, operational ready tooling around these technologies. Next slide. There we go. So a couple weeks ago, actually, we launched yeah, a major update for us, what we called FastFlood Global, really sort of the culmination of the vision that we had originally for what the platform could be. You can just reach this fastflood.org. You can find the model and the tools all there for you to have a look at. So what this is really at the moment one of the only tools that is able to give on the fly, near instantly, detailed flood hazard information, both for historic and forecast scenarios, anywhere on Earth. So this combines this sort of rapid modeling technology with a lot of additional algorithms to very rapidly pre-process all of the data that's required from global and space-based data sets, feed this into the model, and then actually get it into your hands to do, yeah, to see. And then it's not just the static information layer that you're getting, right? It's all done on the fly, including the whole calculations of the flood depths. So that means that we can use it for forecasting anywhere on Earth, giving you high resolution forecast flood maps as well. But besides that, you can also interact with this. You can draw in a barrier, you can draw in a pump, you can draw in a diverted channel, and instantly also get back an updated flood map from that. And that feeds back in then into some of the other goals that we have in the Paratus project, which is, for example, informed decision making, right? So it's checking the consequences of these scenarios during the decision making process in a very effective manner. And also looking at cost benefit analysis in terms of risk, where you can see, look, different scenarios have different kinds of risk implications. So what does that mean for the actual adaptation that we're doing? Next slide. I might be going a bit over time. Sonia, just tell me if I'm if I should round it up, and then I'll do that.
Yeah,
Anyway, it
Bastian,
was
maybe if we can summarize in a couple of minutes the next slides.
yeah, sure.
Well,
Anyways, it's sort of globally available out of the box hazard information as sort of a baseline, detailed up to 1 meter resolution with this new update. About around 20,000 times faster than traditional models could be, and then fully interactive in this web platform. Next slide. We've been applying, testing, and validating this also in case studies around the world for different types of flood events, where we've sort of verified it based on observational data, also leveraging a lot of space-based information. So think, for example, the Derna event 2023, where you get high-resolution satellite imagery of the actual impact, which you can then use to verify the outcomes of the flood model. But we've also done it in the Netherlands and other countries with in situ measurements as well. So that's sort of the modeling stuff that we put together. And next slide. We're adding a lot of additional analytics and forecasting information to that, just to provide additional value to the end users. There's sort of a fine line and balance between giving users the power and flexibility to do their own stuff, which is what some technical users really, really prefer in many ways. And the other side, where there's users that are not savvy with GIS processing, for example, and they really require, in a way, out of the box, pre-processed analytics as well to do the actual work that they have to do with that. So there's always a bit of a thinking that we try to put behind that to make sure that we can sort of address both of the groups there. I'll stop there a little bit with the presentation of what we do, and then you can skip a couple slides and go to the next section.
thank you, Bastian. We will have the time also to explore more in detail fast flood in the panel discussion. So in case you are curious and have specific questions for Bastian, I strongly encourage you to use the chat and we can answer them later. So now I will give the floor to Alex from the Safe Place project to introduce us to this very interesting project. So Alex, the floor is yours. Thank you.
Thank you very much, Sonia. I hope you can hear me.
Yes.
So thank you very much for inviting us. It's a pleasure to present Safe Place. Next slide, please. My name is Alex Roviev. I'm the program manager for Starion Belgium. I work in Brussels for already 15 years, the last 4 of which have been heavily involved in crisis management solutions. Next slide, please. And today it will be my pleasure to present to you Safe Place project, which stands for a safety platform for crisis and emergency. It is currently a project that is done under the ESA CSS programs, Civil Security from Space, which is part of the Connectivity and Secure Communications branch. And it's a 3-year project building up a hardware and software infrastructure to support crisis management organizations with their daily work. Next slide, please. Currently, we are quite a large consortium with many industrial partners, both in Belgium, Spain, and Luxembourg. At the moment, we're looking to expand also to the Netherlands with Bastiaan, for instance, in the future. But we are a collection of industry leaders in all sorts of sensing technologies, both space and IoT based, as well as partners that are already heavily involved in crisis management, response type of activities, such as Bavarian Red Cross, Campus Vesta, an organization that's heavily involved in training first responders in Belgium, PSC, and so on. Next slide, please. In the project, we are currently scoping ourselves to 4 types of crises. We don't handle every possible scenario for each type of this, but try to concentrate on very targeted use cases for the toxic gas leak monitoring, propagation modeling, earthquake damage assessment, and static personnel detection, water level monitoring, flood extent mapping, and roadblock detection, as well as wildfire detection and propagation. The project, as I mentioned, is based in 3 different countries. We are focusing on different things in different countries. Some of the things you will see in further slides. But the idea is that, if you can switch to the next slide, that a platform such as SafePlace would be able to enable faster and smarter decision-making in emergency situations, prevent miscommunication as all data is distributed to all end users in a similar fashion, bridge technology gap where there are solutions available from industrial partners that are not perhaps typically used for crisis emergencies, but now could be utilized in such a manner, or are not widely available to these end users. So SafePlace aims to create that bridge where the end users would only, let's say, subscribe to SafePlace, but will be able to have access to a lot of different technologies, solutions, and products and services. And of course, this should strengthen resilience for the whole community. Next slide, please. Who is it for? So we are designing SafePlace to be primarily for the end users, right? First responders and field units, the crisis managers and coordinators, civil protection authorities is general because it could be potentially used as this fast decision-making tool. And yeah, in the end, also at a higher level, decision makers and policy leaders. Next slide, please. So the concept is that we have a central access point for crisis intelligence, as I already mentioned, based on space information, but also for ground sensing information, simulations, risk assessments, and so on, and should, in theory, reduce or eliminate the need for multiple data provider service agreements between the end users and the upstream data providers. The hardware and software infrastructure is designed in such a way that it could be hosted in a federated fashion, where information exchange could be garnered between the different countries. So obviously there's concerns for data sovereignty, data security, and what we want to do is give the capability to the different nation states to host and secure their own data related to their own activities in their own countries, but allow information exchange for training purposes or cross-border crisis situations in cases as needed. So currently in Belgium, Spain, and Luxembourg, we're already setting up what we would call regional nodes. Still heavy in R&D phase, but already doing some development. Basic idea is that the hub can coordinate and also provide access to shared tools and services through its interfaces, be it user interfaces or also APIs to other tools. Next slide, please. We do have a scope for the current project. So Safe Place is an idea that is currently being developed during an ESA activity, which is currently scoped, but it has a broader vision to enable a lot more in the future. So what we do focus right now is that the risk and evaluation, crisis event, early crisis and response phases, with several functionalities being developed to handle certain aspects of that. So things like advanced warning, propagation and extent modeling when something is already happening, monitoring and situational awareness, so being aware where your assets are, where your personnel is, damage assessment, secure and reliable communication access as well. Next slide, please. This boils down to our information streams where we develop dedicated APIs between our partners and ourselves at SafePlace Hub to provide the data. And then SafePlace also homogenizes the delivery of that information, services, products, and data downstream to the end users, either through a dedicated user interface of SafePlace, which is now being developed only for demonstration, or the ability to provide data directly into existing crisis management solutions, such as, an example here, Safe Brussels, who have their own tools and would not rather have a replacement or a complementary tool running side by side, but would integrate directly the information coming from SafePlace. Next slide, please. This summarizes the scope of technologies that we're allowing access to. So there's, as I already mentioned, weather and flood fire forecasting models. We provide access to ordering of secure communications through a project called Be Secured. IoT sensors to monitor toxic gas levels in specific areas. Wearable sensors, which are meant to be used by the end responders in the field to provide GNSS denied area locational information, imagery from satellites to provide flood extent warnings and thermal imagery data, and also drone technologies to assess damage and detect potential victims on the ground and relay that through AI means automatically on the interface. Next slide, please. Currently, the project is running for a year and a little bit. We have completed several design reviews with the European Space Agency. We've also, to this date, have performed 2 demonstrations, one in Belgium at the European Space Education and Cybersecurity Center in Redu, and the second one in the civil protection premises of the civil protection in Valencia, where we demoed some of the developments that I will talk about later. Next slide, please.
Thank you, Alex, for this introduction to the Safe Place project. So now we have heard from Bastian and Alex what the core activities that the projects are carrying out. And both of you have underlined the importance to develop easy to use interactive tools that go in line with the needs of the end users. So you have also mentioned that you have already involved first responders and stakeholders in the development of these tools. So we would like to explore further how are you ensuring that these outcomes are then sustainable after the project ends. So Alex, you can continue your presentation with this question in mind. Thank you.
Thank you. So in the Safe Place project, we're mainly aiming through a large array of demonstrations. You can start with next slide, please. Where we invite all the local and, let's say, regional partners to directly describe to them and demonstrate to them the progress of the activity. So unlike many ESA projects, whereas milestones are met usually with just project reviews on the project management level, During the Safe Place project, we have a different approach because it's a very stakeholder-heavy activity. We gather these large events with around 70 participants at a time, where we show our progress. Demo 1 is a good example where we, just after 8 months of the activity running, we've already managed to demonstrate some early service integrations. We've showed, together with our partners, flood extent mapping, and Bastian was also present at this event and helped us greatly to show also different capabilities that are already possible with existing technologies, just to actually gauge the also the interest of potential end users. We showed on-site demonstrations of water level monitoring provided from publicly available data sources, detection of stationary objects in affected areas using AI technologies. We've set up even a test area with toxic gas monitoring systems and relayed information directly back to the Safe Place interface. Demonstrated personnel location and monitoring in GNSS denied areas, and demonstrated the capability of delivery of satellite communications, satellite and internet communications without via satellite means. We also showed how potentially Safe Place could work with an additional, with a downstream system like, say, Brussels. If you go to the next slide, please. We do have a small video. I hope it plays. It should appear. And I hope it plays. Technical difficulties. Sort of the developments that were done in the first 8 months. Here we see a reprojected orthographic photograph of an area where victim detection was done. So this was imagery provided by a drone, then automatically mapped onto the GIS system. Alerts for people detection are given on the interface as well. And at the same time, we can move to another area and observe a completely different type of information, where we have a flood scenario being developed on flood extent mapping. So information derived from Sentinel-1 data, I believe, that is again overlaid with satellite imagery, as well as bringing up the information or the data that we're getting from flood sensors that are also located in the area. So the main power of Safe Place, and what we hope to do, is to give the end users a broad spectrum, a broad marketplace, if you will, of products and services all in one place, without the need to set up service level agreements with all the different data providers. And of course, everything can be provided from homogenized APIs, not just through our user interface. So integrations could be made at a level where it is required, let's say, not the entirety of the system. In November last month, we also traveled to Agencia Seguridad and Emergency in Valencia, where we demonstrated the results of the activities in the Spanish side of things, where the focus was the fire risk mapping and fire simulation. There we fuse satellite information on lightning strikes together with ground sensor information from Vodafone's extensive network of sensors located on their towers to provide a very accurate risk assessment map for forest fires, as well as do quite a fast simulation on fire propagation. So again, here we've gathered a lot of agents from Spain. So not only space industry, but also the actual end users, firefighters, different agencies to show them, and also have quite a open discussion on the path of space, let's say space data, and how it can be fused with other information sources to provide actionable information. Next slide, please. There's also a small video where we demonstrate the capabilities of one of the parts of the development, which is the AI chat assistant for Earth observation data. I hope it plays. Which delivers home the, for now, as of now, familiar sort of natural language interactions with a chatbot, if you will, to give you assistance in trying to find the right Earth observation providers for the right time, for the right quality. And in this case, it's answers to a request of a user on what kind of imagery can I get for my given region for this time period. What are the cloud conditions when when the picture was taken, and actually through this natural language interaction can proceed to deliver the service to you. There you go. Next slide, please. So what we have learned through the extensive, very, very involved interaction with the community is that we needed to engage with the potential users very early. We needed to understand their needs and how we can translate them into our developments, into our system requirements. We needed to also build trust and create feedback loops that were assisting our developments. We are a software development organization, so we really needed to understand that we're doing the right thing. We did meet a lot of challenges because each organization has their own constraints, their own goals. We needed to make sure that we contacted the right people in very complex organizations, very large ones. But we had extensive reliability with our partners who do work on individual level with major organizations, and of course their time is very limited, so it was quite hard to get everybody around the table at the same time. But we found that one-on-one interviews with the professionals gave us really good insights, really gave us the understanding of what we need to do in terms of also performance. And these early demonstrations helped us validate some assumptions towards the proof of concept. Large-scale workshops, alas, on the project level at least, were quite difficult to do. Next slide, please. There are extensions in the plans. We are trying to extend the project further in Spain and in Belgium, together also with some parts in the Netherlands with Bastian. But in Spain, for instance, we're moving away from fires and also trying to do flood crisis assistant capabilities, and also extend the Earth observation catalog of services. Next slide, please. And in Belgium, again, bringing more Earth observation specialists in the loop to provide it as a service, enabling higher resolution flood extent and damage assessment. We do play around with some onboard or edge processing for drones, for especially AI algorithms for detection. Together with Fast Hazard, with Bastian, we're working to also integrate flood depth and duration velocity prediction, which is a really great product, as he's already shown, and further extend into the user segment for deeper integration into existing tools. And next slide. I think that was it for me.
Thank you, Alex, for the great presentation and also for sharing your lessons learned that are very precious for all of us, and also the factors of success. So I again encourage you to ask any question to Alex in the chat. Before going to the panel, to the question and answer part, I will give the floor to Bastian again to answer the same question. So, how is the Paratus project and Fast Hazard in particular looking at the sustainability of the product? Bastian, the floor is yours.
Thank you. Yeah, next slide, please. And then slide after that, I think. Yeah, so I'll talk mostly about this from my perspective, right? So within the Paratus project, there's various things that are typically done that are also done there to ensure sort of that some of the key deliverables are actually picked up by organizations that can use them. That involves training, designing it together with the end users in mind, so that some of the output is actually, linked very well to their expectations. For now, I'll mention mostly really about sort of the way that we set this up, or at least trying to set this up with the hazard modeling stuff. And that's an interesting one. Because at the moment, what we're doing is part of that is open source, but really there is a spin-off company that is doing tooling, operation, and making sort of end user ready tools from these technologies, and trying to put that out there. And then the university, the research is happening and continuing on that. That's been quite a new process. Besides the whole fact of the transition of doing commercial work, lots of learning by making mistakes, making agreements about responsibilities between the academic side and sort of the business side of that. There's a couple of reasons why, in particular, we chose this. One is that a lot of the requests that came in were very consulting heavy, which didn't fit well with the university itself in a way. But more so, sort of the tool that we developed and the vision that we had for it had some really nice things about it, which are a bit unique. So the way that you can get a flood hazard map globally at high detail, near instantly. And some of those things are really enabled by a platform that is very heavy on the pre-processing, right? So we take away a lot of the hassle that the user might have to do. But often that means that there is cloud costs involved with that. And that I find in many projects, that's a tricky thing, right? You're building a system that requires a lot of back-end computation and effort to operate for its users in the way that you want it to operate. But then, of course, when the project is done, usually the funding for it also stops. So there is, of course, globally sort of a graveyard out there of platforms and products that have been developed, that have not survived, where follow-up projects, follow-up funding have not come in at a sufficient rate or with sufficient interest to sort of continue the operation of it. So anyway, the way we're trying to approach that and solve that, at least for the hazard modeling side here, is to really prove it by having it available as a commercial product and saying, look, if this is such an interesting technology, it should be able to prove itself and also attract enough additional funding to maintain and operate the platform itself in a viable sense. Next slide. There's a couple problems that we tackle in particular.
Bastian, we cannot hear you anymore.
That sort of help us in the early ones. It's the only use. Oh, sorry.
Bastian, sorry, we cannot hear you very clearly from this slide. So maybe if you can start.
Is it, yeah, okay. So am I audible again? It's okay?
Yeah, now it's
Hello.
better. So if you can start again with the slide. Thank you.
Yeah, sure, no problem. So early warning is one of the things that we're focusing on. We can do global detailed flood maps anywhere. So there's been examples like Jamaica that we've posted also about on LinkedIn. where we were able to do for the whole country a 10-meter resolution a model even before the hurricane impacted. In a matter of 10, 15 seconds, have it fully done and available. Hazard assessment work, but also climate change and disaster risk reduction. In principle, the technology allows for all these sort of new types of usage, new markets, new communities, new sectors, save money and time in terms of the speed. Speed seems like a simple thing, but it does allow for some really neat new use cases. Next slide. So we're trying to sort of set up the way, it's sort of in a dual way where we have sort of the sustainability of the project outcome be through the partners in the project itself that are, of course, using the technology also in the development and in the usage of the tools that come out of the project. But the technology itself is also having a separate, continuation by directly providing it to engineering firms, financial institutions, and also individual consumers and humanitarian organizations. And there's sort of a value proposition that's there. And then the idea is the funding that comes in from that separate stream will help further develop and fund also the research related to the modeling technologies that we're developing in the first place. Next slide. Now, so far so good. We've been doing pretty well. Like it's been a thrill, definitely. It's a bit like a roller coaster, the whole spin-off adventure. But then lots of people have been using it, and there's been a lot of interest to implement it. But one thing also that we found in all of that is that every organization has its own very particular needs in how it wants to use these kind of technologies. And I think through the past years, I've become a bit wary of sort of unified one's shoe fits all sizes, basically that kind of approach, right? And there are platforms that try to do this. But I was very happy to see also Alex mention like, okay, we've sort of found the same with some of our partners that they have specific needs and they sometimes require sort of a specific way in which our technology can be implemented. And I think the solution that you sort of described there, sort of a modular approach, where the system that you design and that you develop during the research project is not usable only within the whole set of tools that are sort of designed and developed, but potential end users can also pick individual modules out of that and link that to their existing systems. And I think that is an important key in being flexible enough to deal with a lot of the regulations and requirements that you encounter when you find new potential end users that are already operating and have lots of rules about how they can do that and how their systems should work. So that I think is for us one of the key takeaways as well. Next slide. Yeah, and then of course, uh, besides that, we're doing all the traditional stuff as well, studies to prove sort of the technology, and it's works with the stakeholders together, and also training, lots of training to help them use it and apply it to use cases that they have a clear interest in. And this is just some examples of application and training sessions that we did for the model as part also of the Paratus project. That's my last slide. If you have any questions on this, I'm happy to continue that and also the discussion on the sustainability issue because I think it's a key one and it's tricky to really get these kind of deliverables and outcomes to survive for decades after your project ends. Thank you.
Thank you, Bastian, and thank you, Alex. So now we have 10 minutes approximately for any question or comment you would like to ask to the presenters. So feel free to raise your hand and speak freely. The audience is quite small, so we can do this in an informal way. in the meantime, that we get some questions from the audience, and I take the opportunity to remind you that you can always use the disaster risk stakeholder app to share any idea, question, or comment on these topics. So everyone is already involved in this space, so feel free to use it, yeah, for your knowledge and explore synergies. Thank you, Ben.
Alex, do you agree with the sort of summary I made? Like you're doing also this modularity to adjust a little bit to the end users that you have?
Yeah, absolutely. Absolutely. It has to be.
How is ESA treating you in that? From the European Space Agency perspective, are they sort of funding you more to do one integrated system and they prefer it to be one whole, or are they happy to have you do a modular thing where other countries, even outside of their original scope, might reuse it in some way?
Well, it's a very good question, quite pertinent, because the ESA funding mechanisms are split between the different countries. Most of them we do have to tailor to their sort of national security needs directly. And during the at least execution of the project, they're mainly only interested in seeing those needs met. So indeed, it gets split off into this modularity by default. But of course, the big vision is that it's the same platform for everybody, for all the countries. Of course, perhaps there are slight differences because not all countries have the same information and data provisions. So it's not unified, it's not standardized. So we do need to make adjustments for that in any case. So same service might not be available in all the countries because there's simply no local data provider or product provider that meets the requirements.
Thank you, Alex. Marcel, do you want to please go ahead?
Yeah, I have only a comment and yeah, we have now all these brilliant tools from Paratus and from the safe place. But at the end, Alex, I wonder because you mentioned you were in Valencia with civil protection. So I'm from Barcelona. We got 1 year ago this flood disaster in Valencia. More than 200 persons died, and we have brilliant tools. But if in the decision chain of who decide what to do, something is not correctly decided, or somebody says yes and the other says no. This perhaps is one of the big challenge that we have to really pass our information with all our tools to the first responder and the decision maker. So I don't know if you spoke. It's a delicate problem, topic, because they are now discussing it. So from your side, a bit of feedback about that.
Absolutely. I mean, this is a very good point because this is also a sensitive subject, right? And a bit out of the scope of our tool developments usually, right? Because we are, cannot influence all the time how these tools are being used and whether they're being used correctly and appropriately everywhere where they should be. So the only thing we can do is to ensure that through our conversations with the different actors, the information about adoption of these tools gets propagated to the right levels. So indeed, talking to, on federal level mandate type of agencies can improve this, but it will never correct for the human in the loop that for instance, is being heavily discussed in Valencia, right? I think that there are some resignations and perhaps even jail times being discussed at the moment. So yes, it's a very good point. But in Belgium, for instance, the approach was that we needed to talk to both very regional level organizations, so regional firefighters, regional police services, federal level, and also these sort of provincial level, all in the same room. So they're all aware, at least what's possible, what's going on. And perhaps they can start the conversation. Okay, well, with all of these possibilities, we can maybe coordinate, we can maybe standardize better. Yeah, I mean, this is our approach. And this is why we partner very, very well with an organization called Save Brussels, for instance. This is the Brussels regional or provincial organization dealing with data management. So they're not even the really end user, but they can be even somewhere in between us and the end user, and the end user is mandated to use their platforms. So I hope that answers your question.
Thank you. It's actually a very interesting discussion, and I'm sure there are also plenty of material that we can read on this human factor component in disaster management. Before closing the webinar, we have a question in the chat from Sophia. So Bastian and Alex, you both mentioned external datasets for meteorological and demographic information. Could you indicate which main datasets you rely on for this type of data?
Bastian, please go ahead.
Yes, sure. We use a whole bunch of them in the end. There's a slide. I don't know if you can show it still. It's sort of a schematic overview of the model with data coming in and then the output on the right side. I don't know. We use a whole bunch and we pre-process a lot to make it easier for the user, but there's sort of several categories of data that you require for this sort of physically based modeling. You can think about like topographical, like elevation, where there's satellite and global data sets. Think Copernicus 30, radar satellite-based elevation products. Things like land cover, where again, satellites do a wonderful job of classifying land cover types, and then you can link that to surface roughness coefficients for the flood model in an automatic way. Think soil types, where there's also global products. There's a soil institute in the Netherlands called ISRIC that makes a product called Soil Grids, which is a global machine learning and profile-based soil product. There's soil moisture from satellite. There's precipitation, forecast, and historic that are, well, either heavily also fed satellite data or using forecasting. Like ECMWF is one that we use heavily, as well as Erified Land, also made by ECMWF, but in a historic data set. There's lots of channel and river related data sets at a global scale. And then for demographic, there's just very recently, so we're trying to switch to that now. The open building map came out from, I think, is it Zurich that did it? I'm not sure which one it was in the end. Marcel, I see you nodding. Yeah, I think it was the University in Zurich that published this, which is a collection of the Google, Microsoft, and OpenStreetMap building data sets. So again, lots of space and AI that merges all of that together into one global consisting building data sets with about 3 or 4 billion buildings. And then they use AI to classify also usage type and height, I believe, in that particular one. So those kind of data sets, if you have any particulars, just please reach out and maybe I can give you some ideas. But then, that's it from my side.
Yeah, from my side, I off the top of my head can only think about the Royal Meteorological Institutes, both in the Netherlands and in Belgium, as well as hydrological societies, open data sets that have, for instance, live water level and quality sensors around the country. So a lot of data sets are also being used directly by our partners. So I'm not fully aware off the top of my head of which ones they might otherwise be. So
thank you. for the question and for the answers. So I very much encourage also to follow up bilaterally the discussion and continue the discussion ongoing on the disaster risk stakeholder app. Thank you very much for our speakers to have introduced us to this new topic in the series, and we hope we will have the chance to continue the discussion ongoing as the project and the products will continue to develop. So thank you everyone for attending, and you will receive the link to the recording. And we strongly encourage you to share with us any idea, comment, or suggestions for the next events. Thank you, Ben, for the support, and see you in the new year for the new webinars.